are collecting donations for the Aerodynamics Foundation, which supports...
Have you ever wondered how these massive machines, weighing hundreds of tons, can lift off the ground and soar through the sky? In this video, we'll break down the science of flight in a simple and engaging way. Airplanes fly thanks to 4 key forces: lift, weight, thrust, and drag. Let's explore each one. First, let's discuss about the lift. It is the upward force that allows an airplane to fly. It is generated by the wings as air flows around them. The wing's curved shape plays a crucial role. According to Bernoulli's principle, air moves faster over the curved top surface and slower under the flat bottom surface. This creates lower pressure above the wing and higher pressure below, pushing the wing upward. Newton's third law also contributes to lift. As the wing deflects air downward, the reaction force pushes the wing upward. Pilots control lift by adjusting the angle of attack, the angle at which the wing meets the oncoming air. However, too steep an angle can cause a stall where the wing loses lift. Now, let's move on to weight. It is the force pulling the airplane down due to gravity. To fly, an airplane must generate enough lift to counteract its weight. Larger airplanes require stronger wings and more lift to support their greater weight. The third force is thrust. It is the force that moves the airplane forward. Without having thrust, we cannot move the airplane. Thrust is produced by jet engines or propellers, which push air backward, propelling the plane forward. More thrust allows the plane to accelerate and generate more lift. Jet engines generate thrust by compressing incoming air, mixing it with fuel, and igniting the mixture to create a high-speed exhaust that pushes the plane forward. Propeller-driven aircraft create thrust by spinning their propellers to pull air backward, generating forward motion. The amount of thrust needed depends on the size and weight of the aircraft, the altitude, and the speed required for stable flight. Now let's move to drag. It is a resistance an airplane faces as it moves through the air. The smoother and more aerodynamic a plane is, the less drag it experiences. Pilots and engineers work to minimize drag by designing streamlined aircraft shapes. The role of wings and engines. Now that we understand the 4 forces, let's see how an airplane's design helps it fly. Their unique shape of wings helps generate lift efficiently. Engines provide the thrust needed to move forward. Flaps, these small movable parts on the wings help control lift, speed, and direction. Also, a flight has 3 main phases. Takeoff. The plane speeds down the runway, increasing thrust and lift until it leaves the ground. Cruise. At cruising altitude, lift and weight balance out, and the plane moves smoothly through the air. During this phase, the engines maintain a constant thrust to overcome drag, while keeping the aircraft at a steady speed and altitude. Pilots adjust controls to optimize fuel efficiency, as fuel consumption is lower in this phase compared to takeoff. The air is thinner at higher altitudes, reducing drag and allowing for smoother travel. Modern aircraft are designed to cruise at high altitudes, typically between 30,000 and 40,000 feet, for optimal performance and efficiency. Landing. The pilot reduces thrust, extends a landing gear, and uses flaps to slow down for a controlled touchdown. And that's how airplanes fly. The balance of lift, weight, thrust, and drag, combined with smart engineering, makes flight possible. The next time you see a plane soaring to the sky, you'll know the science behind it. If you enjoyed this video, don't forget to like, subscribe, and stay tuned for more amazing aviation content.